This conference will now be recorded.
Hi, good evening, Shiva. Your voice is breaking.
Okay. Yesterday there were issues really in Google Cloud. So this was the published by some sound detector. So this in United States and
Your voice is breaking so much, Shiva, actually. We cannot hear you.
yes, all over. Exactly, London region and India, Singapore.
Shiva, you are unaudible sometimes.
Hello?
Actually, your voice is breaking so many times.
Breaking so much. Okay. Okay. Hello.
Hello?
Still not. Yeah. Hello. Not audible?
Yeah, it's
Yeah,
audible
it's
now.
fine.
It's audible now.
Am I audible or still not?
Yeah, we
Voice
can
is
hear you.
The best
breaking.
internet, but maybe lockdown issues. I think. Yeah. Yesterday the issues again breaking.
Yeah.
Again breaking.
No.
No,
it's
good.
fine.
Yeah. Okay. Yeah. So today we will see create the instance first. Okay, so we'll do a small recap of yesterday's session. So basically, so we will write the Docker file and we will build it.
Oh, I
and then we will publish it to the registry. Okay, I can't do anything. I'll try to shift to my mobile net. Be online. So I'm switching the network. Yeah, I switched to network. At least now, is it fine?
Yes, it's fine.
Hello. Okay. So yesterday we discussed, right? First we will write the Docker files and then we will build the images. We will publish the registry. In our case, it is Docker Hub. And after that, if somebody wants those images, they will pull and they will run. So this is the flow, right? Yeah. So we were discussing about Docker file instructions. So a brief recap: work directory is like CD. If you want to move to another directory inside the container, it is work directory. And then user, to switch the user, and then run. So run command will execute at the time of building the image. Okay, whatever the commands you give with run, all these commands will be executed. Label we discussed, like to filter the containers from its base OS, and expose is to show to the user which port you are exposing, and env to set the environment variables inside the container. But we can use this also within the Docker file. So yesterday I did not see it printed the message, but I did not recognize. I'll show you today. So env
So
you can use it within the
we need to mention all
yeah.
the commands in a order wise, or
No,
like
any wise,
from okay.
no need of any order. Entry point is where your container start. Either you have to provide CMD or entry point. If you provide 2-3 CMDs, the latest CMD will be taken. First we'll discuss CMD. For example, if you provide 2 CMD commands, the latest CMD will be considered. Okay, so the difference between run and CMD is run will execute at the time of image building, CMD will execute at the time of container starting. And CMD command can be overridden from the command line. Entry point you cannot override. So if you don't want users to override your command, you can use entry point, but entry point can be amended from the arguments. Okay, and CMD also can provide arguments to your entry point command. Okay, so 2 points. CMD can be overridden. Entry point can't be overridden. We can only
Could you
pass.
please show us example of entry point with the parameter?
Entry point with parameter, this one. If you give ping -c2 yahoo.com, like this. So this will be the command, and the remaining will be considered as the arguments. If you don't provide, you can pass them from the command line.
Okay, so from the command line we can pass it, right? So
Yes.
like we will provide some arg, and in that arg variable we'll pass some value. So right. So how will we do if we are doing like this? Could you please show an example in the command line also?
Arg I will come back. Arg, there is one more instruction arg, I will come back to that. So arg is different.
Okay.
This is CMD also can pass args to entry point. Okay, so there is a clear reference in Docker file. So always we need to refer Docker file reference from Docker Hub. So entry point has 2 forms. This is executable form. What is your executable command and what are the params you are passing? And without that also you can use shell form, but the preferred format is execute form. Okay. So this is from the documentation. So always they say use the executable form. This is called executable form. Okay. So that's CMD versus one, and we discussed add and copy also. Copy can only copy the files or folders from this current directory. Add can be used to download HTTP based files also. Yeah, so that's all. Okay, so let us discuss one more thing called arg. Okay, so we'll discuss arg. Arg is like while building the Docker image, if you want to pass some arguments to the Docker file, you can use arg from CentOS. Suppose if I say arg port equal to something 80, now echo $port if you print. Okay, so if you pass argument, this port will be replaced with the whatever the value you are going to pass. If you don't pass, it will consider this default one. Okay, so we'll see that. So that will be useful. We will use that arg while installing Apache server. Okay, cd arg. Oh, arg I created as a file. Okay, so now what is the command? Docker build -t, usually your username slash the image arg v1 dot. So while building, I want to pass some arguments. So here the syntax is -build arg port equal to 8080. Okay. So now you can see the port is printed as 8080. So at front, you can give some provisions to the users. They can replace the values, just like in any programming language, we pass some arguments, right? Same here. Okay, so this is all about the Docker instructions. So I will show you one simple HTTPD setup, and then later we can go for a complex one, and you can understand how the people can reuse your images. Okay, here I will create one project, images. Suppose to host your website, you need Apache web server. So in your company, maybe you are hosting a lot of websites, right? Everybody cannot to go and create their own Apache web server. So we can expose that as image, and so that people can use and host their websites. Okay. First, I'll go with M-based installation. Later, we will go with the production level installation. So this will be very simple. From CentOS and run yum install httpd -y, and so we will provide the arguments arg. If user don't provide, we will run it inside 80. Okay, so when you install httpd, so what it will create usually, it will create var www/html directory. So inside this directory, we will place our HTML or some folders. Okay, so and this one, it will create /etc/httpd directory. So inside we will have all our okay, for example, I will show here yum install httpd -y, and we will start systemctl start httpd. Let's go to etc httpd, and there will be a conf directory. Inside that httpd.conf, here you can configure it however you want. See, now it is listening to the 80. You can change it to the whatever port you want. So similarly, you can do a lot of configuration changes according to your company. We do some changes. So now let us do a change of listening to the port. So I set the path is, if you want to change it, port is there inside /etc/httpd/conf/httpd.conf. Here, if you want to change the port, run, and then there is an SCD command to substitute any line inside the file. Okay. So I want to substitute list and listen. So I am searching this one. This symbol means starting with. I am searching inside a file a line with starting listen 80. See first, change it to listen, and whatever the port you want, /port. So which file it is? This one, httpd.conf. So before that, we have to launch inside that directory. We will give work directory and this one. Okay, so when you install the web server, you are going inside this directory and changing the port number 80 to whatever the port the user gives. If you don't give anything, we will take 80. Okay, so let us try this command here itself. For example, I give, okay, so I will set a variable port equal to 8080. Okay, here we cannot give Docker variables here. So let's put 8080. and see whether it is changed or not. Okay, so I forgot one escape sequence here. Here up to here. Okay, so now you see it is changed to 8080. Okay, so it will be here, escape sequence. So a line starting with listen 80 should be replaced by listen whatever the port you give. Okay, and then so we'll write our entry point httpd -d foreground. If you don't give foreground, this container will run the server and it will exit. Your command should be in the sense like to make the container always active. Otherwise that will run the command and it will exit. So container will always do the work whatever you have given to it and it will exit. It will not stay. Okay. So this is the simple web server. Okay, let us see whether how it will work. So I will first stop. I'll clone it. So this AutoGit is a plugin inside VS Code that will automatically commit the code to the GitLab. So if I say 3 seconds here, it will push the changes for every 3 seconds. So I need to restart it after I do some changes. Push 10. Again, this is okay, some problem. I'll push it manually for the first time. Your branch is ahead of master by 1 commit. Okay. Git push origin master. Pen. I'm not allowed to push to this repository. So This project can be the requested URL to project. Maybe I selected any wrong options while creating it. Let me create one more. HTTPD image this time, public 805. Okay. Status git add git commit. Just give me something. How to reset git creds refreshing. Maybe it is past some company credentials. Credential manager. Just give me 2 minutes to Windows credentials. Okay, so that was due to some cache. So I'll just add my Docker file. Okay, so now we will build Docker -t and then sudo Docker 469 colon httpd colon. So let's give as v3. So now we created the images. Let's see how it is working. Docker run -d. Since it's running in foreground, we have to send it to the background colon v3 and then so let's give the port -p 80. It is running in background 80. If you want to give name, we can give it name web1. Now Docker ps. It is not running, some problem. Docker logs. Syntax error, port must be specified. So our build image did not run properly. Here, I think maybe this one is a problem. So this we ran it successfully there, but here this port may not be clarified because we are using single quote. Now we will run it again. From daemon, you have to remove that container to okay. The name is there, same name. We'll give web2 docker ps. So now this is running and exposed to port number 80. Now if you go and give port number 80, so this is working. So this image I will publish in my company. So now I will ask developers to use this image. Now, so they come up with some project. For example, QI, we have our code QI, right? The developers are, assume developers are creating one project. They want to make use of your code. So we have some QI code. QI in the sense, it's our project earlier. So developers, assume this is developers mission.
You are pulling from GitLab or what? Means
I'm pulling from GitLab. Yeah. So
the code is there in.
we'll create the project. We'll create the project in GitLab, right? So this is some sample HTML code. So this is some
Okay,
sample
because
HTML code. So in real time, developers will develop this code.
and in that you're putting in a container means.
Yes, I will put this project inside container.
Okay. The GIT pull will just
See
pull
now
up.
what git pull is that's a git command, right? So I'm uploading from here. This is from my desktop. I'm uploading to the GitLab. So where is your Docker daemon running? This Docker daemon is running in this server. Here we need to build the image.
Okay. A Docker file is a Docker
So
image only, na?
Yeah. So here also we will create one Docker file. Just see. So please wait for 5 minutes. Your doubt will be clarified. So now the from image should be which one? Whatever we create the image here, right? This should be the from image. Because this has everything. V3. So this is the from image. So now we have to place our files where www html. Currently the image is in this directory. So now first we have to go to where www html. I will copy my files to this directory. Okay, that's it actually. So now let's run this and check. So I'm pulling that repository. Okay, so here we will go inside and let us build this docker build -t -qy version 1 dot. Okay, it's not pushed. So these are the commands to push to the Docker central repository. So now we have created our image, our website image. Now we'll run this docker run -d in background and v1, and we'll expose the port. Port 8 is already in use, so we'll use 8080 and this one. Now docker ps. So this our QI is running. Now if you access this with 8080, our website is came up. So if another person wants to host their own website, they will simply use our image within their company. Okay, any doubts?
Please write the steps in a order. What you did know.
What?
Please write the steps in order. What you actually did. It's a little confusing. Yeah.
Yes, okay, I will put it in the diagram. So to run any website, we need web server, right? Generally, first we will see the normal process and then we'll put inside images. So if you have developed some code, this is your host, I mean your physical server. So inside this, you will have your Apache server or Tomcat server. So this is your host. So this is your Apache. I'm talking about normal server, okay, not any Docker based. So here we will place our code. Correct. So here we will place our code. So inside physical server, you will download and install Apache server and you will place your code. So this is the normal implementation. Now we will see the Docker implementation. I'll just remove this. So after this, you understood? You understood this?
Host means our machine, right? VM, right?
Yes, your machine. Yeah, your physical machine.
Okay. In that we have
So
installed
don't
Apache
confuse
server.
between physical machine. Yeah, this is logical server. This is a web server. This is physical server. So we will install one server, either Apache or Tomcat, and inside that we will place the code. So whenever users request IP address :80, right? So we are running this Apache server on port number 80, correct? So if any request comes to port number 80, your server redirects the request to the Apache. So inside it, it will serve this code. Clear?
Okay.
So now we will see the Docker way. So Docker is nothing, it's just another server inside the server, but lightweight. So this is your host. And I will request http:/IP address :80. So inside I mapped here, right? If I get a request to 8080 on that IP address, I am asking the Docker daemon to forward that to the 80. So on 80, what is running? Our Docker container. So here I installed Apache server and I exposed port number 80. Okay, but here, sorry, this is 8080, right? 8080. If somebody requests 8080, request will first so I requested like http IP :8080. So this 8080 here by this command, what you should understand is whenever a user hits my host with 8080, forward it to this container, I mean this whatever we ran on port number 80. So this container IP address is known by Docker daemon. So it will forward that request to container on port number 80. So on port number 80, we are running our web server. So then the code will be coming here. Understood the flow?
That Docker container also placed in a host.
Which one?
A Docker container.
Yeah, Docker container also in the host. Now, if the request is more to your web server, you will create one more. More
Like
and more,
auto
you will create one more.
One more
Yes,
container.
like auto scaling. Yeah, one more container. So you can run as many containers as possible, right? Otherwise, generally what you have to do, you have to buy a new VM or you have to spin up a new VM.
Yes.
Again, you have to install Apache server inside that. Again, you have to host the code inside it. Correct? So like that, maybe imagine you are maintaining 10 servers to serve the load. And inside the 10 servers, you have to install Apache and you have to install the code. So that will be more costly. And the performance is also, so you need to install load balancers in front, everything, right? But here also there is some problem. If your containers are more and more in the same host, if the host itself is a problem, if the host itself got corrupted, what will we do? All the containers also will be not responsible, right? If host itself is down, you cannot connect to any container. So in this purpose, yes. So whatever you are running, it is all inside the host. If the host itself is down, you cannot do anything. Correct. So generally, what is the solution? Normal solution, you have 3 hosts. Generally, without containers. On top of, on below, you will have one load balancer. And this load balancer is connected to all your servers. And user request from here. The request first goes to load balancer. Correct? So when a request is received by load balancer, what it will do is it will do health check. Whether this server is responding, this server is responding, this server is responding. Okay, if all servers are responding, then randomly it will send the request to the 1 or 2. So in all the servers, you have your Apache server and the code. Okay. You understood this flow?
Apache server is in container, right?
No, I'm talking about normal flow.
Normal flow. Okay.
Forget container. So this architecture everyone aware of, or at least when I'm saying you are understanding, right? So just to run a single website, what you are doing here, you have to definitely should have the more RAM and more CPU. Even your website is consuming 20-30%, you have to buy the RAM, you have to maintain that server, host server and operating system. You need to install the patches, everything you have to take care. Correct? So that is where we have one point, resource optimization and cost optimization. And this is a heavyweight server. This OS itself may be 2 GB like that. So spinning up, booting up that much OS and on top of it, hosting a website, the performance will be definitely degraded. So now you can, we have discussed 7 characteristics. Now you can compare those 7 characteristics in this architecture. Any doubts still here? Now we will discuss how Kubernetes will address this architecture. So I can discuss how Kubernetes can address.
Shiva, so I just hope
So
you are
here,
not going. You will not go very deep about Kubernetes today, right? Because we have so many things
no,
to practice.
I'm not. No, I'm not going any deep.
Yeah, because for now we need a lot of practice to do. Because
Yeah,
I'm
definitely.
really
I'll not go deep. I'm just discussing the need of Kubernetes, because at one point of time, if you are running more containers, right, that is also a big overhead to us. This is node means server only. So I will spin up 3 nodes and I will attach those 3 nodes to the Kubernetes master. So all these nodes have Docker daemon running. Just like how we install Docker. So we'll install Docker in all these nodes and we will attach it to the Kubernetes master. So now as a developer, you have created this QI website.
Hello, Shiva. Hello.
Yeah.
Yeah. Node 123 means the different VM.
Yes, different VMs.
Okay, means each VM running one container.
In the nodes, you can run as many containers as you want.
Yeah. In
So like,
your diagram.
yeah, in my diagram, this is host or node or server.
Yeah, there are.
So
Yeah,
inside
there are
it, run
3
as
servers.
possible. Yeah.
Yeah. Okay. Got it.
So now I asked QI website, for example, to spin up one container. So it will randomly select these nodes, whichever is up and running. For example, if node 3 is a problem, it will push the container to this. So what my QI website Docker file have generally. So I'm pulling the images, right? So here I will write some declaration. Means declaration what? QI v1. This is my code. QI version v1 is my code. I ask this Kubernetes master. Then this Docker daemon inside it, it will connect to the registry Docker hub. So I created the image here. Now I will push it. Docker push. Before that, I will log in. I should log in, right? Docker login. Now I logged in. Docker push. And I will publish this one. Okay, here while requesting Kubernetes, there will be a YAML file. So in that, what I will tell to Kubernetes master, a master pull QI v1 from Docker hub and run 3 containers of it. Okay, so you will send a command to Kubernetes master like this. Then Kubernetes master will check what are the nodes running. If all 3 nodes are running, intelligently it will pull the image from it and it will ask 3 nodes to spin up the containers. Okay, I asked it 3. So for example, here one container 1 and here container 2, and here container 3. If suddenly node 3 is down, Kubernetes master again intelligently detects that, and it will transfer this container to any one of this node. So that at a time, if, for example, here 60% of your nodes, because of some natural disaster, this node is not corrupted, it will intelligently detect it, and it will intelligently transfer those containers into the another node. As a user, you don't care from wherever it is coming, but still your website is up and running. So that is QI. Some other developers may do another website. So all the websites are scattered along these 3 nodes. If your 3 nodes are very busy and more, you can spin up node 4 and you can attach to Kubernetes master.
The same was done by load balancer also. Load balancer also check the health check, right?
Yeah, load balancer also do the health check. You mean normal architecture, right?
Normal IT. What is the difference between means load
So
balancer and
difference is,
Kubernetes also?
yeah,
It doesn't pull
here
up that
difference,
image.
here
You can
different,
go
yeah,
ahead.
here difference. It will not pull down. It is not able. This is not container. First of all, don't compare. This is container. So the difference here is your cost, your resources,
Okay.
your management. This is not intelligent enough. If something is down, it cannot spin up
Spin up.
automatically. Like self-healing. So if something is down, it cannot detect it. It cannot transfer it to another node, right?
But one thing, means load balancer will check the health check, right? Health check is the same as spin up. You're saying health check.
Yeah, health check it will do. But what if all the 3 containers are not responding? Here, it will do the health check as well as it will maintain all the time your 3 containers.
Okay, all the time the 3 containers.
All the time 3 containers, whatever you request for.
Okay.
So you don't care whatever it is. So that Kubernetes will take care of it. Where to run those 3 containers, how to run those 3 containers, all the things it will take care. But here, everything you need to do. You need to configure these servers. Everything you have to take care. And for example, when you do a code change, yeah, last point, when you do a code change, you have to install the code again into these 3 servers. But here, what you will do, you will increase v1 to v2, and you will push to Kubernetes master. Kubernetes will master remove all the Q1 versions. It will pull down the Q2, and it will run into all the 3 nodes. And you see how soon we are able to run these containers within a seconds, right? When you run the Docker run command, within a seconds it is coming up. So very smoothly your containers will go up. If the traffic is decreased, it will come down.
Shiva,
And there is no any downtime for container. I mean, there is definitely crash like.
See, if all the 3
Container
nodes
can
crashes, we don't do anything. We can't do anything.
Okay.
so
At least
Shiva,
one node should be live. Yeah.
so Shiva, like Kubernetes master, right? So that has to be maintained by separate administrator, and like he has to
Yes.
clearly need to monitor that all the containers are in sync, or any jobs will be scheduled like that.
Yes, we will have monitoring for this host also, whether node 1 is running or not, node 2 is running or not, node 3 is running or not. And inside that, if any container is running, so there is something called ELK. So this Kubernetes master will do the health check for containers. The container is not responding, immediately it will transfer. It will try to spin up within the same node. And if this node itself is down, it will transfer here. And we always have the application logs. This Kubernetes master will fetch those logs and it will publish to wherever you want. So we are going to discuss ELK and then Prometheus in that case. So we will monitor these nodes also. We will monitor these nodes, and using ELK, we will monitor the applications running inside container. So maybe confusion, but leave about Kubernetes. So now you are aware of creating the images and publishing those images, right? Anyone still have doubts? So why we need Kubernetes? If you don't have Kubernetes, you have to log into every node and you have to spin up the containers. Correct? That's what the manager. Remember the orchestra diagram. So if this is one person, this is one person, this is one person. If there is no person in front, you need to go to every person and tell him, do like this, do like this, do like this. You have to keep on telling all this. If you have a person in front of them, all these persons will be watching and they are following the instructions. Same in this case, Kubernetes also. You are passing the instructions to Kubernetes master. Kubernetes master is passing the instructions to the nodes, how to behave, what to do with the images, what to do with the containers. So if you think in a general perspective, it will be very easy. If you think in a very low level, what's going to happen, how Kubernetes, that may be difficult for now. But while doing practice, it may be easy for you. So for all these containers to run, first thing you need images. You need to create the images and you need to publish to the Docker Hub. And in this YAML file, we will tell Kubernetes master what to do with those images.
What is the purpose of ELK here?
ELK is for logging purpose. So inside Kubernetes, your application is creating a lot of logs. How the developers can see the logs.
Okay, it's for only logging purpose, not a monitoring.
ELK is basically
Monitoring, monitoring we can do with Prometheus, that will be very effective. ELK is only log monitoring. Log means something, if something goes wrong, some defects suddenly come up, then we will do with ELK. If you want to monitor the host, we will do with Prometheus. ELK is for, yeah.
One thing,
Yes,
actually,
yes.
we are making the images of CentOS and HTTP, Apache server, Tomcat server. So nowadays, most of the bankings they have using some Oracle WebLogic or something like that servers, application servers.
Oracle WebLogic, no one is using Oracle WebLogic. Everybody is coming out of it.
Okay, but now still we are working with the Oracle WebLogic only.
Okay.
In banks. So we can also make an image of that, right?
No, that will be very heavyweight. Suppose if you want to see the web server, server statistics.
Okay.
2018, for example, or 2019. Which application server 2019 statistics.
So, but nowadays we are using that.
So now everybody is using Apache, Tomcat, and Spring Boot, right? So WebLogic is very, very rare.
Okay, Oracle WebLogic.
Yeah, WebLogic, WebSphere, Java, all those are very, very rare now. So now if you see this 2017 statistics, so Tomcat is 63.8. WebLogic, you see, it is 4.5%. In 2018, it will be further decreased. Those are legacy applications.
Oracle WebLogic or what? Okay.
Yeah, so all these are legacy, JBoss, all these are legacy. So this is lightweight. So if you want to run some web, some application, you need very minimum components. But WebLogic, this JBoss, WebSphere, all those are heavyweight servers. You don't require those things. That's why this Tomcat is getting popular. If you see 2018 report, it occupied further more. In 2019, it occupied further more.
Which one? This one, JBoss. This one, Apache one.
Tomcat, Apache or Tomcat, yeah.
These are the Java based, no?
Whatever we discussed now. Yeah, WebLogic is also Java based.
Okay.
See,
But
now
it is
if
on
you see, Spring Boot is popular, Apache Tomcat is popular.
Okay.
Because microservices, we can't run microservices in WebLogic.
Microservice. And what about the database? Means
Database will be on-premise servers. Our Java servers will be inside here, and database servers it will get connected. You can
the
have
database.
still your DB. Yeah, you can have your DB here outside of the Kubernetes cluster. So all your applications connected to this. But now companies are working towards bringing the database also into Kubernetes.
Okay.
So containers concept is just making your physical server and then the web server, application server, and code into a single component.
Mm-hmm.
So in this case, it has what? Physical server and your web server, application server, and code inside. These three components, a big fat server. Here it is. But what we are doing here, container. It will have the base OS. Here also you have OS, and here also you have Apache installed. Here also you have code. Here also you have base OS inside the container. Correct? We have base OS.
Okay.
We have server. We have code also. So everything we have, right?
Only
so just,
the OS is
I
about.
told you. Yeah.
The OS
So
side
OS.
is only, no?
Yes. So Docker definition itself, lightweight, executable image which contains necessary system tools, libraries in bare minimum to run an application. So you understood this point?
Yeah, got it.
Docker or container?
Container. Docker is one of the company providing the containerization. We have another also like Rocket. So the concept is Docker. So the concept is container. We'll discuss the replacements again. Just think container, I mean lightweight OS. On top of that, you can do anything. So that's what we have done till now. We have taken lightweight OS.
Okay.
Yeah.
Got it. So Docker file
lightweight
is just
OS. Yeah, Docker file is the instructions. How you want.
Just like
what are yeah, just like pom.xml, right? If you understand Java, or like makefile. So this is how you want Docker to install that. So this is 230 MB. So they are giving base OS. Your Docker Hub will give base OS. On top of it, what you want, that is your wish. Okay. So any more doubts? You should be only convinced to the single point. Container is again a lightweight, which have everything.
Sure. In this way, how can you define Docker? Do you mean to say any facilitator or interface between the hardware and container?
Yes.
Something like that?
Yes, good question. So if you understood whatever till now we have discussed, right? So forget Docker. So what we are doing? defining instructions to make image, creating image, and then creating container out of image. This is what we are doing, right?
Yep.
So this is a concept. To do this, Docker is a company providing this solution. There is something called low-level runtime and high-level runtime. So low-level runtime means if you have image already, it will just run your image. High-level runtime means it will manage the image, will manage the containers, expose web APIs to connect Docker daemon. Okay. So how is managing the images, like versioning, storing inside the host, right? And then resolving the images. So here I define like this. So it will fetch this automatically, correct? In case of low level runtime, whatever the image you provide, it will run. That's it. It will not do any other thing. For example, when you are installing some VLC media player, that installation is connecting to the internet and it automatically fetching some files whatever it needs. That is high level runtime. So reducing our work is high level runtime. So Docker, the high level runtime is provided by a software called container d.io. So whenever we are installing Docker, so you see we have installed something like container d.io. Container d.io. So this is the high level runtime actually. So this is the high level runtime software. Okay, so Docker is using this one. Docker is not providing all this actually. Docker in background is using this one. On top of this, Docker is what Docker is special then. So this container D, it does not speak about how to make the image. That is provided by using Docker file. A declarative approach to make image. And then it is providing Docker Hub to store the images. And it is providing a rich UX UI. So container d.io is the main thing behind Docker. It's a high level runtime and Docker is using this one container d.io to manage the images and to manage the containers, to expose web APIs, all those things. And on top of it, it is providing this one, declarative approach of how to make the images. So now we can also start one company, like we can have our own file like this, and we can use this containerd.io, and we can also host something like Docker Hub, and we can also start another company like Docker. It's a software suite.
My container is open source or what?
Yes, it's open source. Containerd.io. So now if you see, there are a lot of runtimes, but Containerd is famous because of its rich features. Containerd is one runtime, and CRIO is another runtime, and there is something like Fracti, all those things. But out of that, Containerd is providing lot of good features. See, now you can see this. We got the image. So this is low level graph. This is high level graph. Which one is leading? Containerd is leading. This CRIO and runc, all these are not providing good features. Because Docker selected Containerd, Docker became famous. Okay. I hope I'm not confusing. Just compare. So you can compare this with programming languages. Java also building applications, PHP, Python. So all these things are to create the applications. Java has its own syntax, and ultimately the purpose is to host a website. The users does not care, right? So what you are using in the background, whether Java or Python, Java has its own syntax. Similarly, Dockerfile, it has its own syntax. If you use any other thing, it has its own syntax. Ultimately, the concept is to create the containers out of any technology and to host it so that people can access it. Because Docker is providing some easy features, everybody is using Docker. And you have Docker replacements also. So PHP, creating websites in PHP is very simple than Java, correct? So we have Rocket containers, like Docker containers, we have Rocket containers, Mesos containers. This is from the Linux itself, OpenVZ and Containerd. See, an industry standard container runtime with an emphasis on simplicity, robustness, probability. So Docker is a wrapper on top of Containerd. So that's why it became famous. Any doubts? So we can stop till here today. If you practice 2-3 times, it will become easy. We have already script to install Docker, so we know all the instructions how to use, and you have the script also uploaded, HTTPD simple. Still, I thought to tell one more thing, but for now it may be heavy. This is very simple, right? 4-5 lines. Just you need to understand while writing it. That's it.
Siva, just one question.
Yeah.
So, Siva, Docker is a company name, but the concept is containers. But mostly companies, mention Docker only. I mean, I'm not sure if they mention Rocket or any other provider, but mostly they mention Docker only when they ask for containers in the
Yes,
interviews.
container. That's why we are learning Docker only. We are not going to learn Rocket D, something like that. So here itself you can see, right? So it's a popular runtime for today, and so none of them is going to replace at least in next 5-10 years, at least next 5 years.
Okay.
It's easy. So now let us simply run something to give you more confidence. Let's run Jenkins. We'll see how easy to install Jenkins. So normally how to install Jenkins, you have to go into one physical server and you have to install inside Jenkins, and you have to do lot of configurations, right? But here, if you type Jenkins, they will do everything for you, and they published it as image. Yes, they will provide instructions how to run this. We have not discussed yet about this one. Volumes we have not discussed, right? So I'll just remove this part. So how soon you can spin up Jenkins? That's what I want to say. That is just because of the lightweight containers.
Means you are
So all the companies.
means you're directly getting the container, Jenkins container, right?
Yes, directly. So all the companies, they are moving. In our company also, we are moving towards containerization. Jenkins also, we are moving into the Kubernetes. We'll spin up master, we'll spin up slaves, everything into the hosts. So that when the more builds come up, right? For example, at a time, we got 1,000 loads. We can spin up the slaves easily here, wherever we are. Otherwise, you should maintain the slaves physically, right? That's very costly and very difficult to maintain. Oh, what is already allocated? See, now Jenkins is very fastly spinning up. Okay, on 88. Can you install like this in VMs? So normally you can, but whenever, suppose if suddenly some request comes up, so to make it available is very difficult, right? think some settings we need to do. Okay, any more doubts? So we'll run Jenkins also inside containers while discussing Kubernetes.
Shiva, is there any chance that we can see CI/CD in this
Yeah,
course?
CI/CD. Yeah, that's what we are going to do. So when we spin up our applications inside Kubernetes, we'll spin up Jenkins master as a container, Jenkins slave also as a container, and then within Jenkins we will build our images, everything. So
actually total ga final Jenkins as a container, database as a container, application server as a container,
everything is
totally
container.
all the components in
Yes, you can run everything as a container.
Unless I really doubt.
Yeah.
Actually, in work locations also, Jenkins for the Jenkins purpose, we need this Windows or GUI GUI OS.
Windows.
Actually, we
Windows.
are using the CentOS.
Okay. For what?
Actually, for Jenkins, we install the Jenkins in a container. So we need to give the IP address. So where can we give the IP address in a work location in a real time?
You mean Jenkins IP address?
Jenkins IP address. Anything in a GUI, graphical interface, like Jenkins, like Git,
No,
Git
so
GUI.
that is completely different.
In a real time,
Here we will have something called a DNS. So we will have DNS. So for example, you have a website, right? For example, ibm.com. You can make it jenkins.ibm.com. So it will take you to the Jenkins of your IBM. You can use gitlab.ibm.com. So what will happen here inside Kubernetes, it will detect when the request starts with Jenkins dot, I need to send it to the Jenkins container. If the request starts with gitlab dot, I need to send it to the GitLab containers. So like that it will resolve. Okay. So this is host based. This is host based. There is one more way, ibm.com/Jenkins. If it is like this, then after this, right, whatever comes, this goes to the Jenkins container. So like that we can work. See here also it is docs.docker.com. Okay. So if no doubts, we can end this for today. So I don't want to discuss more today.
fine, Shiva.
Sure.
Okay, so I'll just practice this. We'll connect tomorrow. Maybe if you practice and come up with some doubts, right? So we can have again some discussion so that we will be clear for the Kubernetes. Okay, thanks for your
Sure,
time.
sure.
Have a nice day.
Shiva, so
Tomorrow.
when we will start our regular classes, so can we go again with Docker, because it's a very short course, right? Just 2 days, or Docker is enough?
No, still will be coming. So when we are discussing Kubernetes, also still we have to make the images.
Okay.
Still we have to write Docker file.
So
It's
from
a
here
continuous concept.
we will connect start Kubernetes as well and Docker as well, right?
Yes. Docker will be there continuously. So we nowhere can escape from Docker.
Okay.
So whatever you are providing to the Kubernetes, those are Docker images only.
Okay, because I have left behind like 1 or 2 means yesterday's session. So actually I was practicing yesterday's session. So yesterday and today is actually pending. So if we go
Tomorrow we'll discuss very light. And Saturday, Sunday, we don't have a class maybe. So then you can complete it.
So tomorrow do we have class or we have class?
Yeah, tomorrow we can have, but we will discuss very light concepts, not too much. And then we have the weekend, right? So you can watch this Docker again and again, and then from Monday we can start some little deep.
Okay, got it.
Okay.
And you will also share the examination point of views, right? Like
yes.
certification examination.
So it's a CKA level, yeah. So once we enter into the Kubernetes, we discuss everything. So similarly, we can create the repos and I can share it to you.
For CKA, right?
Yeah.
Certified Kubernetes Administrator. Okay, fine.
Okay. Have a nice day. See you tomorrow. Good night.